these things after the presentation. You can find me at the SandGround booth. But enough about me. You're here for the main for the presentation. That's value-oriented design. And before we dive in, I just want to set the agenda and put the to set the tone for what we're going to be talking about today. Um, throughout these years, I kind of just found out that the patterns that we're currently using, while I didn't really understand them in the beginning, I see them emerging in different frameworks. So we're kind of just seeing, how do I say, a convergence of solutions or practical implementations of concepts that do bring scalable front-end solutions, or to say frameworks. And oops, my pointer is the way. And these are fundamentally rooted in concepts like immutability. You have value at the center. You have values at the center of building, how do I say, composable user interfaces. And these concepts, we're just going to look in the practical and theoretical implementation. So without further ado, the main topic is value-oriented design. And I want to ask you, when you see this, how would you answer the question, what is a value? And usually, I think most of us would relate to something that's kind of subjective. So when you look at this painting, it does have its subjective value because you kind of relate and resonate with what's on the screen. And it's also really an important piece of art because it's from, I think, it's from the most Bulgarian painter, Vladimir Dimitrov, the maestro. So all of us can recognize this painting, and it has its, while subjective, it also brings intrinsic values, right? It does, it is painted in a way that can be quantified. So the brush that's been used, the style of painting that's been applied. But this is how people would treat values outside of programming. When as programmers, we kind of look at values that look like this. And values for us are usually just abstractions over space, right? So this is something that it's important to us because this is what's been stored in memory. And while our applications, they do have some, how do I say, just procedural aspect to them. They're transforming values. They're also, the end result is that we can persist this in memory, and this is what's important for us because we're building information systems. But it turns out that managing values in the contemporary state of JavaScript is kind of difficult, and we end up with code that kind of just looks like this. And if you can't really make sense of it, I'm just going to zoom out a bit. And it's still quite difficult to grasp what it's doing. And yeah, I'm just going to zoom out a little more. And this is part of a script that's, I didn't make this up for the demo. This is from the most famous e-commerce websites right now. And this is their, it says here, highlighting functionality for whatever they're doing in their UI. So we ended up with something that looks like this, but how did we got here, right? So imagine if you get asked to add something at this part of the script, you really wouldn't want to do that, right? It's gonna be, you kind of need to know everything that's happening before it and all the things that are actually connected to that part, because it's, in a sense, because it's kind of mutable. So I started thinking, why are we building systems, or like how is the industry have come to some solutions that are for managing this kind of behavior, and why did it need to come to these solutions, right? And I found myself just hovering around two main reasons. The first one is the language is really helping you to avoid this kind of behavior, and I think it's we should be it's in the name, right? It's JavaScript, so it's a scripting language, and it was designed to bring small interactivity to the web page. So back in 1995, it was mostly doing stuff that looked like this. So for the set of challenges it was designed to do, it was doing those really well. But we're now living in 2024, and in 2024, while the language has not changed significantly, right? We had two main releases, ES5 and ES6, but those happened around 2010 and 2029 and 2016, 15 respectively. So until now, before that, it was really difficult to handle these complex interactions. But browsers were continuing to evolve, so we did get more asynchronous operations and more complex UIs that were touched, and a lot of things were happening simultaneously. But our code primarily was kind of just stuck in semantics to look similar to this. And the second reason that I think the language is kind of not helping us to manage these complex scenarios is that imagine if you're Brendan Oich, I hope I'm not butchering his name, but he developed JavaScript in 1995, right? So you're conditioned to think about a set of challenges, and your peers around you, they're what? If they have like 10 or 15 years of experience, they've been developing for systems that really should really carefully manage their memory. So this is a construct that allows us to really carefully and really precisely manage memory. We can overwrite what's at a certain portion of space. And this was good because memory was the most expensive part of a system. In the 70s, that would like run you $1 million for a megabyte. Now it's the cheapest part of a system. So in the 80s, and so does this influence that he had by, or how do I say, conditioning that he had by peers of his time could lead him to build APIs in the language, or just tools in the language that let you be really precise about your memory. But now we don't really need to do that. But at some place we still do it. At some places we still do it. So how can we make our code easier to maintain, more predictable, right? This some part of the application is going to mutate data value, so the next time you're looking at that portion of space, you're going to see that the value it was representing was something else. And I'm just going to coin this into like a broader question that we want to answer today is, how can we design applications to be more predictable and maintainable? Yeah, right. Who knows? If I had the answer, I guess I would give it right away. But I think that Brendan was early in the mid 90s. I am conditioned to believe that the challenges and the tools that I'm using are the best for the job, and probably someone is in 30 years' time is going to be like, they were doing reactive development or functional programming, and this is no longer the norm. So in a sense, I can't really give a definitive answer, but for us now, in the current state that we're developing, it kind of depends on the challenges that we're trying to solve, and the tools that we have now, they do help us mitigate, or just they do help us build more resilient UIs. But again, this is conditioned through the context of the current time that we live in. So I really want to show this graph because I said that there was an important event in 2015. Promises, or ES6 was introduced, so it did give us promises, it did give us generators and iterators, and these were tools that helped us synchronize asynchronous events. So after that, you see an explosion in framework development, which if we take it for just to infer what I think this last column means is that it's not easy to do, right? If it was easy to do, we would still be here. But I started working in 2018, 6 years ago, and the dominant framework was React, and I was conditioned to believe that React is the best way to solve complex UIs, and this was the tool that SiteGround, the how do I say, the libraries, the fundamental library that we were using for building our applications. So this leads me to this quote that there was pressure for the industry to improve, and when you see pressure, there is progress. And we saw this proliferation of frameworks that all seem to have this one common pattern in mind, and that's to make changes unidirectional. So in the first example that we looked, when we were updating data value, we were actually going against the flow of execution. So to make it unidirectional, React, what it does, if you're not familiar with the syntax, this is how you push updates to React to re-render its DOM. So it has new state, which is a derivative of your previous state, or the output of some operation, and you assign the previous state to the new state. And the more savvy of you have probably already noticed where the problem lies here. Can one point to the problem? It's object assign is a mutable operation. It doesn't actually give you a new reference in memory. It only modifies the existing memories. So in order to make this work correctly, you need to introduce a new object. And then React is going to compare, okay, so this is a different reference. So yeah, render. Key takeaway, we should be able to easily detect change. And usually this is, how do I say, this is described by having immutable behavior, and detecting detecting change combined with immutability, I would say, is more like we should be able to detect emissions in time, right? Because what these two objects had in the beginning, when React couldn't really tell the difference, what was going on, was that both of them, they have space and time combined in a single construct. So if you give it a new object, it could hold the same value, but it's a different portion of memory, so it was created at a different time. React would be able to tell that it should re-render. So to recap, should be able to produce unidirectional data flow, so we're not overriding values, and we also new values. When we're updating a value, these are kind of related. We're introducing a new object to the to the process. Third thing, building a relationship. As in React, as in life, important, but I'm not here to life coach. When we think about reactivity, how would you describe it in like the physics world? Where something reacts when there's an external stimuli applied to it. So you need a force to be exerted, and whatever you're exerting the force on should be able to respond to that change, to that force, and it's going to react. So relationships in programming, they look like this. And to build a relationship for a reactive system, we just need to kind of like be able at runtime to tell that two modules need to communicate with each other, or to build a tight relationship that whenever one changes, the other one should change as well. So we're gonna just walk through a small example that's gonna implement this. And I really don't want to dive into the implementation, just want you to focus on this part of the screen. So when we have an app state, that's going to be our A module. We're going to have a DOM updater, that's the second module, and we're going to link those two with an on-state change function. And you can see from the logs, when those two were instantiated, they built a relationship. And this is just something nice I had. Whenever the relationship is created, it would also run its update function with the new state. But if we want to modify this, how do I say, we want to modify the string on the page, we would dispatch a new event that's like this, with payloads and a value of hello JSTalks. So, and we emitted new data in time, we reacted to that change, so we kind of just accomplished our main goal, and that was to build reactive system. Unidirectional data flow, relationship in our code. And this is like how reactivity should be like. But I think a subtle detail in reactivity should be who owns the relationship. In this case, what we did was we need to be able to identify who owns the arrow. So to build a reactive system, what we did was on state change, we forced the DOM updater to perform some work. And this is usually not how reactivity works. You should be um, it should come from within, right? The DOM updater should be able um, to, to react to the change, but now it was forced to react. So app state was proactive in the way in that it tried to change what's on the DOM, and it only knew how to do that because DOM updater exposed the method. So to just keep the direction of the arrow but change the ownership, we're gonna make the producer of data, in this case app state, listenable, and we're gonna change the DOM updater to be reactive. And this can be achieved very simply by just passing app state to the DOM manager and subscribing this on the inside. Now we don't have to return an update DOM function and to find how do I say, how to find how the behavior of DOM manager is going to be defined. We need to only look inside the DOM manager, because in the previous example, we could say that in order to find out how the DOM manager is gonna work, we need to find all occurrences of each module that's invoking the update DOM function, and now all of this is combined in a single module. So the behavior is we've inverted control and we've injected a dependency, which are in this case the good patterns that how do I say, other that are defined in the industry like as good patterns, right? So other people and we've as a community have come to the realization that this is something. Yeah, this is good. Wow. So to recap, I'm just gonna unidirectional data flow. I'm gonna merge those two together because produce emissions over time and mutational awareness are kind of just saying the same thing without, or saying the same thing with different words. We need to build a relationship. We need to subscribe to changes. So, is there a data structure that holds all of these things? Right? Is there some cons that can exert all of these behaviors? And I think there is, and that's what referred to as an observable. As observable, there are a single const. They do create different emissions in time, which can easily detect, and they, in this case, they exert a push behavior, which we're going to analyze. We're going to look into why push is important here in a bit, but this is RxJS's definition. It's quite packed. We're going to describe each of its components separately. So lazy would imply that an observable would not perform any work until it's subscribed to. Push is the way data is being propagated to subscribers, and collection meaning that while you could return a singular value, it's more powerful when it's pumping out multiple values like collection. And in implementation, a really simple implementation of this would look something resembling this structure. It's you have a constructor that accepts a subscribe function, and the subscribe function is going to be the output of is going to be a function that accepts an observer and returns a subscription. Subscription is just an object that has an unsubscribe method. It's give the value of that function inside a private variable, and then it's only going to invoke this when subscribed. So it's not going to perform this subscribe function until subscribed to. And just for sake of completeness, this is how the rest of the definition would look like. And I think something curious here is that the interface of the observer kind of, how do I say it? I was thinking, why would it be in such a way that it would require an error and onComplete, right? We know that onNext is expected, but when talking about collections of data, we could either reach the end of the collection gracefully, in which we would run the onComplete, and the other way is to have a thrown exception, which we also need to handle. So we're gonna look at a little bit more code. This time, I'm gonna focus on this part because the implementation here is of observables. I'm gonna have those pushed later to GitHub. You can find me at Kiril ZH. But what's important here is that we have produced, before we were dispatching events manually. Now we have created from a source. We have created a subscription. We have created an observable to which we're actually enhancing behavior. We're actually applying behavior enhancements to handle transformation and the bounce, and then we're linking this to a subscription which is going to perform that effect. And this is going to be really easy to follow along. If we here search for cats, well, it's not going to perform a real asynchronous request. We have mocked this behavior. We see that each value was pumped to the map function. The map function was then piped to the bounce. And this is the push behavior, right? Because we notified each subscriber. In this case, the transformation observers. And we see that the bounce function, when it reaches its 500 millisecond debounce, in this case, is going to invoke the last subscription, which in turn turns this, which in this case is going to pass this to the which this case is going to pass it to our subscription. And I'm just going to walk you through this a little, just like this. So just it's a little easier to follow along. Okay, now we can see the source of the event here, the input element, invoking its next whenever from here on input we handle the event. We call the observer next method. We then pipe this to the map function, which transforms this observable, transforms this value, sets it to the timeout function, which is going to invoke it whenever the timeout passes, and we're going to run this last subscription, which is going to perform fetch data. This is a really primitive example, and you're also going to fetch data is going to be part of this observable transformation that's happening, but you're going to need to use, in that scenario, something like RxJS, which is going to perform a switch map over this, and it's going to become really nice. But for sake of simplicity, we're going to keep it like this. And the key part here is that we're separating a producer and a consumer. So back to our presentation. This behavior that we saw, we were the latter, how do I say, the bottom right corner, because asynchronously we were linking asynchronous events to perform another asynchronous operation. But in practice, if you're dealing with a purely functional language, you would also have even the most primitive of data types, the value, can also be turned into an observable. And in RxJS's definition, anything is an observable, and like you saw, we could transform, even the transformations can become observable. So an example, when a primitive data type becomes an observable, that's going to be its set and get methods, if they had those. In the language, they're considered implicit because you just assign a value to a variable. If it had a set and get function, the set would be the consumer side because it receives a value and it returns nothing, but the get would be the producer side because each time you get data, you can subscribe to that data, and it's always going to return a value, but it doesn't accept a value. And one last thing here, I want to mention that while we're talking about reactivity, if you're familiar with Eric Meyer, he really hates the term reactivity. He calls it side effects. That's why in RxJS, you're not going to find the word reactivity written anywhere, because what we're in truth doing here is just managing side effects. And if you want to learn a lot more about this topic, I would also recommend checking Chris Kowal's work on general theory of reactivity. He goes really in depth about the different patterns you can build with this type of behavior, like an observable. And yeah, if you want to, GTOR is what you need to look for. It's he's written this in his GitHub account. What we've taken away from his work is something that we have become, how do I say, we've come to the same realization. In our products, we use this multiple consumer method and the broadcast behavior when talking about observables. So, zooming out even more, we can think about side effects as just having a producer and a consumer. Somewhere in your application, data gets produced. Somewhere in your application, data gets consumed. This behavior is what the industry has kind of just has discovered to be what can bring you maintainable and reusable code, so you can just plug small, let's say, transformations in different parts of your application. Then you can use other methods like the multiple producer and multiple consumer side to synchronize those events. And like I said in the definition, it did set push behavior. This really depends on the type of data you're using in your application. Push is good for data that's discrete. It's countable, right? Each event is distinct in time, and in those scenarios, you can debounce if you get too many events or the stream gets really heavy from the producer side. So you can, like we introduced this input, debounce each event so we didn't perform a fetch operation each time as the character. But whenever you're dealing with continuous data, this would not work, because imagine if you debounce something that's continuous, right? The estimated time of completion, it's always going to change. So you need, in those scenarios, you're better off to just request a new instance of your data. So a behavior, which is in the singular realm, you can think of it as invoking a function, right? You invoke a function, you get some data. So yeah, this is how do I say this is these are the two ways data gets transmitted. So yeah, the pooling behavior, while you're gonna lose some fidelity of your measurements, it's gonna be still just as accurate. I've mentioned here that view and svelte behave in the push how do I say, in the push realm. That's just to illustrate, because while React is called React, it's not reactive. Whenever we are actually scheduling updates, whenever we call set state with a callback, or with a how do I say, with just a value, you're queuing your updates in the scheduler of React. React is in control of his pulls from the scheduler and decides when React has the power to decide when it wants to update the DOM, and it can prioritize other work. In the meantime, while other applications need to handle this yourself. So, how have these principles actually helped us in our day-to-day work? Well, we're currently working on our email marketing campaign tool and another tool that's soon to be released. And you can see that if you look at our source code, you're going to see something that looks like this, which is really similar to this observable behavior. We're handling our communication layer between the control panel and the iframe, which holds a preview of our email campaign. Through an observable, we're just not performing those modification of data. We're receiving it raw and syncing it to our React application through a use effect that stays subscribed to the middleware exposed by we call it an engine. And then that data gets passed to the page content. With that, I hope we've shed some light because on the patterns that the frameworks that we're using are actually employing under the hood, because this producer and consumer is really licensed of most front-end frameworks right now, and we see behaviors from each other. So we could see we could see some convergence on the scene, but there's I know there was a talk today, quick. I didn't have the chance to attend it, but I know that it does a really clever thing where we mentioned that the reactivity graph should be built at runtime, and Quick bumps this a notch by having the reactivity graph serialized and passed to the application, because Quick uses its server-side rendering like it's gonna walk through the whole tree at least once, and it knows which part is connected to which part, so it doesn't need to have this execute at runtime. It's serialized and passed to the application. So they're calling this resumability. Coming back to this, it could be rewritten looking like with observables. It could be rewritten to something that's more similar to this syntax, which we could reason more easily about what it's gonna perform. And this pattern can help us optimize really complex behaviors. But I want your takeaway from this session to be use this based on its merits. You could read all about observables, reactivity. You could check Eric Meyer's work. I'm not gonna pretend him, right? Because he's really clever and he's the guy standing behind RxJS, and also a lot of work for Microsoft. And while it is a powerful pattern, it is what the industry is using right now. If you need to build a simple interactive web page, you could still stick to the basics, because I think succinctness is power, right? If you need to write a lot of code would equal to a lot of bugs. We need to be really precise in our, how do I say that? In the code that we write, and if we could write less, it's always better. And with that, these have been just my thoughts while I was developing this presentation. I hope you like it. If you have any questions, I will be happy to answer them. So thank you. Yes. About the next event. Sorry, I could not speak on behalf of the organizers, so you should talk to them. This has been the template slide for me. Yes. Um, that, it's a great question. Unfortunately, I haven't spent a lot of time working with Angular or Quick outside of just building really primitive examples. So I don't think I'll be the best influence on that matter, on that topic. It's just that I'm kind of seeing patterns that exist in each framework, and if in each different framework. And if you were here in the morning session that Ilya Idakiev actually hosted, he said, I don't really care what framework I use today anymore, and I'm kind of just leaning in to this, how do I say, to this kind of thinking, because fundamentally they would solve your problems. You should just be aware of how they do it, because like I said, React has it does have a specific syntax, it does bring you um, some goodies in with that, but it also, if you want to like the most performant, how the most performant state view updates is probably not going to be the best because it's kind of heavy and clunky. So yeah, with that, just um, research it. How do I say it? Just do your research beforehand really well, and I think you're not going to be wrong choosing each one. So until um, it's not going to be the bottleneck, the framework's not going to be the bottleneck of the implementation, I think. Anyone else? Yes? Yeah. Signals. Yeah, I saw that signals have entered the scene. I know there's a proposal in TC39. There's also, something I kind of just forgot to mention that, yeah, we do have these tools right now, but I also see them, some of the core concepts from these frameworks are being proposed in the TC39 repository. So there is a proposal for observables, there is a proposal for signals. So we could see that those get natively implemented, and we're probably gonna write with different frameworks that because it's gonna be more performant to do this in the vanilla way, in the vanilla language. But um, signals, I'm still having a hard time a bit just um, in implementation to find their place. I'm kind of just looking at them and I see how it can be achieved um, with other tools, and I know they have this. I know they have their specific. How they have their. They're solving some specific set of problems, but I'm. I don't think I'm the expert to answer that. Yeah, sorry. Anyone else? You seem like you have a question to ask. No, I'm joking. These are my colleagues, so